Assalamu alaikum everyone and welcome back to my channel. Over the last few videos, we have gone from our raw data set to a clean, feature-rich collection of data ready for modeling. If you haven't seen those videos, I highly recommend watching them first to understand how we got here. The links are in the description. Today is the day we build our predictive model. But before we write a single line of code, we have to answer the most important question. What kind of model should we use? Let's think back to our correlation metrics. We saw that a few of our features like degradation score and forecast score were very strongly correlated with our target, but most of our other features, the vibration data, the temperature, and the wind features, showed very little to no linear relationship with the outcome. If we were to use a simple linear model, it would struggle to find any meaningful patterns in their data. This is a classic scenario where the relationships are and hidden too deep within the time series for a traditional model to capture effectively. This is a clear signal that we need to bring out the heavy artillery. We need a model that can learn intricate non-linear patterns from the sequences of data. And that's why today we are going to build and train a hybrid deep learning model using PyTorch. Alright, let's get into the code. We are in a new file model.py. That first thing we do in any deep learning project is set our random seeds. Deep learning models have a lot of random initialization. By setting a seed like this, we ensure that anyone who runs this code gets the exact same result. It makes our work reproducible, which is critical for good science. After setting our random seeds for reproducibility, the first thing I want to define is the custom attention module. This is a key part of our model, so let's break it down carefully. So what is this doing? Remember, the LSTM will output a vector for every single timestamp in our sequence. We need a smart way to combine all those vectors into one that represents the entire sequence. A simple average would treat all the timestamps as equally important, but that's rarely true. Some moments are more critical than others. The attention class learns to find the important moments. Here is how. We define a single linear layer. Its job is to take the LSTM's output for a timestamp and boil it down to a single number, a score. Softmax function then takes all these scores and squashes them into probabilities that add up to 1. The timestamps the model deems most important will get a higher value, for example 0.8, while unimportant one will get a value very close to 0 like 0.001. These are our attention weights. This is the magic. We multiply the original LSTM outputs by their corresponding attention weights. This amplifies the important timestamps and diminishes the unimportant ones. Then we sum everything up. The result is a single context-rich vector that is heavily influenced by the most relevant parts of the sequence. By creating this as a separate module, we can neatly plug it into our main model. Now for the heart of our script, the model itself. We are building a hybrid model, which means we are combining the strengths of different neural network architectures to create something more powerful than the sum of its parts. Our model is a class that inherits from PyTorch's NN.module. The init method is where we define all the layers of our network. Our hybrid approach has three main components: the 1D convolutional neural network, the long short-term memory networks LSTM, the attention mechanism, and the final classifier. First, the data will pass through a 1D CNN. Think of this as a feature extractor. It slides a small window, a kernel, across our time series data and learns to recognize the local patterns, like a sudden spike in the vibration or a dip in a temperature. It is incredibly effective at finding these low-level motifs. The features extracted by CNN are then fed into an LSTM. LSTMs are designed specifically to understand the sequences and context over time. By making it bidirectional, our LSTM can look at both past and future data points to make a more informed decision. It's learning the long-term relationships between the patterns that the CNN found. This is the secret sauce. Not all moments in times are equally important. An attention mechanism allows the model to learn which parts of the sequence are the most critical for making a prediction. It will assign a higher weight to the most informative timestamps, effectively telling the model pay more attention to this part. Finally, the output from the attention layer is fed into a standard fully connected or linear layer. This layer takes the high level feature representation and makes the final prediction, classifying the data into one of our damage classes. Defining the layer is one thing, but the forward method defines how data actually travels through them. Now let's look at the forward method. This is where we see why we need the permute function. Neural network layers in PyTorch expects their inputs in a specific format. This is where many beginners get stuck. Let's trace the data shape. Our data naturally comes in the shape like batch size, sequence length, and num features. PyTorch convolutional 1D layer expects the channel or feature dimension to be in the middle. It wants the shape like batch size, num features, and sequence length. So x.permute is the command that swaps the dimensions. We are telling PyTorch keep dimension 0 where it is, put dimension 2 in the second spot, and put dimension 1 in the third spot. This rearranges the data perfectly for our CNN. After the CNN, the data is still in the CNN's preferred format, but now the LSTM layer wants the format to be batch size, sequence length, and num features again. So we simply permute it back. This might seem a bit strange, but it is very common and necessary step when you are combining different types of layers like this. From there, the data flows through the LSTM and the attention layers as we discussed, finally producing our output. This careful management of data shapes is key to building complex models in PyTorch. So in a nutshell, let's see what actually is happening through this forward method. The data X comes in, gets reshaped for the CNN, passes through the CNN, get reshaped again for the LSTM, goes through the LSTM, gets focused by the attention layer, and finally produces an output from the classifier. It is a beautiful and logical flow of information. And there you have it. We have just built a sophisticated hybrid deep learning model from scratch in PyTorch. We made a deliberate choice to use this architecture because our initial data analysis told us that simple models would not be enough. We needed a model that could find complex nonlinear patterns in the time series data, and this CNN LSTM with attention is designed to do that exactly. This model.py file is now the brain of our operation. In the next video, we will write the training script that will feed this model our data, train it to make predictions, and evaluate its performance. If you are excited to see how the model performs, make sure you are subscribed so you don't miss the thrilling conclusion. Thank you so much for joining me on this deep dive, and I will see you in the next video.